Dear student, welcome to this video of chapter 5, where we will speak about protective equipment, not discussed in other courses, or maybe it is discussed, but partially, but here specifically for gas carriers. So we'll speak about level alarms, about gas detection, water spray systems, and the emergency shutdown system. The level alarms, each tank must be equipped with an independently level alarms for the liquid. That means you will have a high level alarm around 97%. You will learn in the labs in one of the next sessions even, till how many percentage you can fill up your cargo tank. That depends on the temperature of the cargo. Yes, the cargo you receive. So it's not always 98%. No, not at all. It is most of the time it is limited to a lower percentage. You will have your first high level alarm at 97%. This is most of the time, this is to give you an audible and visual alarm by saying, hey man, watch out, because you're already at 97%. It might be already too late, this warning. Yes. In some cases, if you receive your cargo too warm, too cold, that you must stop before that 97%. There is another independent sensor that will activate your very high level alarm. And the very high level alarm will only activate at 98.5%. Then, for sure, you are overloaded. That is for sure. There's one exception, that is LNG. In some cases, you are allowed to load more than 98% of LNG, but it's very exceptional. On an LPG, it's definitely not allowed to load in any case over 98%. So this very high level will not only give you a visual and audible alarm, but it will also activate the ESD. So it will prevent you from overfilling this tank, and it will automatically shut off the tank completely and stop the pumps. Gas detection, you have on board two systems of gas detection, namely a fixed gas detection and a portable gas detection. The fixed gas detection, that is your life assurance. A gas tanker is safe as long as there is no gas detected inside compartments where you don't need the gas, of course. Therefore, the fixed gas detection is a gas detection that runs 24 hours on 24, 7 days on 7, the whole year round. You will only stop that one when you are in dry dock, but for the rest, it is always running. It is your safety. It is an automatic system that will analyze the atmosphere in all compartments where there is a possible accumulation of gas vapors. It will warn you automatically to say, hey, watch out, because there we measure some gas. That is not a common situation. Portable gas detection, that is for the operation. That is mainly used for operations of preparing tanks or changing atmospheres in tanks. Then you use your portable gas detection. That is for the cargo, while fixed gas detection is especially for your life, for your well-being, for your safety. Okay. Gas detection, a fixed gas detection should analyze atmosphere in these different locations. Here you see a list of gas detections on an LNG carrier. So there is one in the interbarrier space, a second one in the interbarrier space, because it's always top and bottom. In the installation space of number 1, number 2, number 3, number 4, there is in cofferdam number 1, 2, 3, 4, 5, a fixed gas detection that's in the duct keel, forward and after gas detection. There's gas detection in the gas vent drain tank, in the bosun store, in the pump room, in bow thruster room, under the passageway, and in the tank vent mast. This is what we call a sequential system. That means it will measure here, and after 30 seconds of analysis, it will go to number 3. 30 seconds later, it will go to the next one. 30 seconds later, 30 seconds later. This can take maximum a half an hour, and then it should be back to the top one. Half an hour later, the whole system has been done, and so on. So sequentially, all these locations have been analyzed. So one gas analyzer can do these 31 locations. But on top of that, we have a constant monitoring system on LNG carriers, which do the cargo machinery room, the motor room, the gas pipe duct, that is the pipe that brings the LNG from the deck to the engine room, the gas hood, that's the extra safety around it, and then the gas inline after the dryer, and the ESCR, I don't know very well what that stands for, directly the emergency, no, I don't know, engines, I don't know. And that space does also is then detected. That means that here, for each compartment, you have a separate gas analyzer. You have a separate gas analyzer, and that is constantly analyzing this room, and this room, and another one this room, and another one this room. So this is constant monitoring system. For the sequential system, we have a pump that is continuously bringing air from each compartment to outside. It is only by these solenoid valves that one sample is chosen to send it to the flow meter and to send it to the explosion meter, and then outside. If this one has been analyzed for 30 seconds, the solenoid valve changes, this one changes, and the next one is sent to the explosion meter. So this is the sequential system one by one. Most of the time, this gas detection central is situated in the cargo control room. It should give you an alarm around 20 or 30% of the lower explosive limits. Then it should give alarm. It can be that there is a pre-alarm at 20, for example, and another one at 30% of the LAL. This I told you, I just told you. Every ship should be provided with at least 2 portable sets, but these 2 portable sets are then mainly used for the operations to analyze the atmosphere inside the tanks. All right, then on top of that, we have on board of every gas tanker a water spray system with which you can create a water curtain to protect certain areas on board from fire. So this is on top of the fire line system. Water spray system is quite a huge installation where you have nozzles installed around accommodation, for example, around the midship superstructure, around deck tanks, for example, around the domes, around the manifolds. All these are protected by the water spray system. So here, for example, you have a deck tank. You see that is with ammonia, loaded with ammonia. And this line, this gray line here, is then part of the spray system. So on the inner side, you don't see it here, but on the inner side, it's at regular distances, it's equipped with nozzles. So you can send seawater through this line, and the whole tank will be under water spray and protected from heat whenever there is a fire on board. The capacity of this water spray system should be at least 10 liters per square minute per minute for horizontal surfaces and at least 4 liters per square meter per minute for vertical surfaces. This is a huge amount of seawater that you need to do the whole ship. And therefore you have a large pump available. Watch out when you start this pump because you will have control of the pump also from the control room. When you start the pump and there is not sufficient electricity available, you have black out for sure. Huh? Okay, just to prevent that too much water is lost, you have also on the system different isolating valves. So if you have a fire in the aft, there's no use to send water to forward side here. So there are isolating valves at regular intervals or for different compartments. But this gives you an overview of which locations are protected by this water spray system. In fact, you simply have to start a pump. Some valves can be operated from a distance, others are manually, so depending on how new your ship is. This is a mimic diagram of that whole system. You have here that seawater pump which is located in the engine room. Has a huge capacity, and so it can be sent by these automatic valves, can be sent to the different consumers on deck. But since this seawater pump is there, it is also used to feed, for example, the cargo heater or the condensers. At that moment, when you use the cargo heater, this pump has been tested also. In case you need it, it works. The water spray system should be tested at least once every 6 months. Don't forget to rinse it with fresh water, since otherwise all your nozzles will be blocked with salt. And finally, of this small chapter number 5, we will have a word about the emergency shutdown system. So the emergency shutdown system will shut down your system once it is activated, but in a specific way, since there is an interaction, since there is an interface in between the ship and the shore ESD. This was not always the case. That means that when you activate the ESD system of your ship, you could have a large, huge surge pressure ashore. Suppose when you are loading, then the pumps ashore are running full speed. You suddenly activate the ESD system of your ship. What will happen? Big catastrophe, of course, ashore. So that is the reason why there is an interface between the ship and the shore ESD system. And that is also the reason why all the valves from the ESD system needs a certain closing time, which is situated around 20 and 30 seconds, something like that. Depending a bit on the local authorities. For the Coast Guards, if I remember well, it's 20 seconds. So main purpose of a linked ESD system. With linked, I mean the system between shore and ship. So in order that if you are loading, the logical sequence is that you stop first the shore pump and then the ESD valve of the shore, and only then the ESD valve of the ship. In that way, you will avoid surge pressure. What are the events that could initiate the ESD? Well, we'll only look into this side, on the ship side. You can, of course, manually activate the ESD. For example, you see a big leak, which you cannot handle immediately. Well, you activate the ESD system, everything will stop, and you can repair the leak easily. Automatic drip shutdown signal from shore, if the shore has a problem. Overfilling of a cargo tank, as I indicated, at 98.5% level, you have an independent level gauge that will automatically activate your emergency shutdown system. The power loss to the valve controls. If you have now no power anymore over the valves, it is possible. Oh no, it is not possible. It will activate your ESD system. Since all valves are of the safe fail system, that means when there is no power anymore, they will all go to their safe position. Loss of control of air pressure, ESD valve moving from full to open, that if it is fully open and it starts moving for an unknown reason, that will activate also the ESD. ESD logic failure, if somewhere in the software or hardware of the ESD system something goes wrong, then you will have also an ESD. If there is fire in the cargo area, you have some of these melting plugs that will activate the ESD automatically. Or if there is a loss of electrical power, you will also have initiation of the ESD system. This will result in a shutdown signal to the shore. This will result in a trip of the ship's cargo and spray pumps. This you can always stop immediately. When there is an ESD, you can always stop the pumps. That will not do any harm. Stop the booster pump in case of LPG. Trip the vapor return compressor. So on board of LNG ships, you have these high duty compressors that are running and sending vapor back to shore. These will be stopped automatically, and then when all that has been stopped, you can start closing your ESD valves easily without damaging the rest. This is a mimic diagram of an example of a simple ESD system. This is a pneumatical system. It's safe, it's pneumatic. So there is no danger of any electricity. You have a certain pressure in these small lines over the whole system. These are the different activation points where you have melting plugs, where you have manually operated valves. The working element is quite simple. You need a certain pressure inside these lines, for example, 7 bars. As long as there is 7 bar in the system, nothing is happening. But as soon as your pressure drops below the PAL value, the pressure alarm value, let's say that it drops to 5 bars, then the ESD is activated. So if you open here a small valve to activate the ESD, what is happening? The air is escaping into the atmosphere. Pressure in the line is falling. As soon as it is decreased to 5 bar, it will activate the ESD system. Same thing happens with these melting plugs. If they melt, air can escape from the ESD system. You'll have low pressure and then activation of the ESD system. So the fail-safe type, if there is a failure, all valves will go to their safe position. For some it is open, for some it is closed. Depends on which valve we are speaking about. On the LNG, we have a double ESD system. Namely, we speak there about ESD system 1 and ESD 2. ESD 1 is the basic system, the one we explained, but on top of that, we have the ESD 2, which is the ESD 1 system, plus an emergency release of the loading arm. So this emergency release system is what we call the dry brake concept. So that this is a release system which is isolated by 2 butterfly valves, one above and one after the disconnection location. Normally ESD2 initiation is done from shore after ESD1 has been activated, of course. So we have here a butterfly valve, we have here our disconnection, our release coupling, and we have here again another valve. So as soon as these two valves are closed, we have here a very small amount of gas inside so that we can safely open the emergency release coupling. And that the ship can sail because the ropes, the mooring ropes will be released automatically also. Tugs will be connected and you will be tugged to sea. So that's it for this chapter. Thank you very much and hope to see you soon in one of the next videos.